Welcome to today's class. The differentiation for the equation y is equals to xx. Here the function look like x and x has a relation with x dot x, right? So if we differentiate both sides, so d by dx of dy, I mean to say we are differentiating with respect to x, indeed dy by dx, and right side d of dx x dot x. Here actually two variable, so x dot x. So we know there is a equation or there is a rule, d of dx uv rule, which can be written as u dot d of dx plus d of dx. So here we have taken u and then differentiate v, and now v and differentiate u. Same way we take this x and then differentiate dx by dx. So this x is here and this x is here, right? Plus now x here and d by dx. So here will be x. So dx by dx, it will be 1. Dx by dx is equal to 1. So x plus x. So the answer will be 2x. This is the answer. In this problem, the equation y is equals to x to the power x. So the function is x to the power x. For this differentiation, we have to do like to change the position of this x. How we can change the position of this x? Let's take logarithm to both side. So ln of y is equals to ln of x to the power x. What will happen? So left side ln y and this x transform to this position, so it will be x and ln of x. Here we have actually x and ln of x. Now if we use the chain rule of differentiation, by using chain rule, so what you can write down, so of course we have to differentiate with respect to d by dx, I mean with respect to x. So ln of y is equals to d by dx. So differentiate both sides with respect to x, x dot ln of x. Here if we differentiate this term ln of y, what will happen? It will be 1 by y, and we have to differentiate the whole term of y. Indeed, we could write down d of dy. Now here u and v, so let's write here x. So d of dx ln of x plus ln of x d by dx and x. So what will happen here? So by the way, let's write x as usual. Now d of dx of ln x, so it will our rules, like if it is ln x, so 1 by x plus here ln of x, and dx by dx is 1. So this is the right side value, and the left side is actually by the way, I made a mistake here. It should be d of y respect to dx, right? So this is our final target to determine. So we can write down dy because the main function was y. So dy by dx is equals to this one, and this y will transform to right hand side as a relation of multiplication with the term. So the final answer dy by dx is equals to y x. By the way, x dot 1 of x means it will be 1, and here ln of x, and this is plus. So what is the value of y actually? That is x to the power x and 1 plus ln of x. So this is the final answer. Find the derivative of the function f of x is equals to sine 2x squared minus 6x. So the differentiate rule, d of dx sine theta is equals to cos theta, and this theta we have to differentiate. So d theta over d theta, because we are differentiate actually with respect to theta, so it will be theta. So sine theta differentiation means cos theta, and this theta we have to differentiate d theta by d theta, so this will 1, so cos theta. Now if we differentiate sine of 5x, what will happen? Of course this will cause 5x, so we have to differentiate d of dx, this 5x. So if we differentiate dx 1 and this 5 and cos 5x. So this is the rules of the trigonometric function of differentiation. Anyways, now if we differentiate this problem as mentioned in the question, so you could write down d over dx of f of x equals to d of dx sine 2x squared minus 6. So we could write down sine convert to cos, and what is the angle here? 2x squared minus 6, right? Now we have to differentiate this angle, I mean the value of theta, this one. So we have to write down d of dx 2x squared minus 6. So if we differentiate this part, it will become 2.2, and x to the power 2 minus 1 means x, and oh, by the way, here need to be write down x. So here need to be write down x, here x, so it will become minus 6, right? And what left? This whole part left, so let's write down cos of 2x squared minus 6. So the final answer will be 4 of x minus 6. Of course the first bracket is very important here, cos 2x squared minus 6. So this is the final answer. So here the function fx is equals to sine e to the power x cube. So if we differentiate this part, I mean the function, so f of x, because here x is the variable, that's why we are differentiate this function with respect to x. So we could write down f of x. The function f of x is equals to sine e to the power x to the power 3. This is the function, right? So the basic rule we need to know, d of dx, if it is sine theta equals to cos theta. If it is e to the power x, means e to the power x if we differentiate. And if it is x to the power 3, then it will be 3 minus 1 mean 3 x square, right? So if we differentiate this part, it will become cos e to the power x to the power 3. Now we have to differentiate this whole theta part. So it will be d over dx e to the power x to the power 3. Now e to the power, it will be cos actually. So it will be cos e to the power x 3. Now if we differentiate this part, what will happen? It will be e to the power x to the power 3. Now again we have to differentiate this part, right? So d over dx and x to the power 3, because here actually not only e to the power x, it will be e to the power x cube. Indeed, we have to differentiate x cube as well. So we could write down this part first. So 3 x square and then dot e to the power x cube and cos of e to the power x cube. So this is the answer. In this example, the function f of x is equals to square root tan of x square plus 1. So if we consider the u of x is equals to x square plus 1 and v of t is equals to square root of tan t, and if we compare the function f of x is equals to square root of tan x square plus 1, so we could write down f of x is equals to, if we compare this two part with the main function f of x is equals to, we could write down v and u of x. So v means square root of tan, so v, then u define the x square plus 1. Hope you understand. Now if we use the chain rule, and of course the main function is f of x. Indeed, if we differentiate the f of x with respect to, so the chain rule, very first one will be d of v over dt, as the variable is t, times d of u times d of x, right? Now if we, by the way, before that we need to know the basic equation for basic rules for the problem. So if we differentiate d of d theta, if it is tan theta, the result will be sec square theta, and d of dx, let's say this is square root of x, so it will be half x to the power minus half. This is the basic rules we need to know. Anyways, now we need to differentiate d of dv over dt. So it was square root of t, so d of dt square root of tan t. What you can write down? We can write down half, if we write down tan t, so it will be minus half. The very first equation, the second formula, and this is first formula. So the second formula, if it is 10 whole to the power half, so half minus 1 means minus half, and we have to differentiate this part as well. So d of dt over tan t, right? So this part, if we differentiate the tan theta, what was the result? Sec squared theta, right? So we can write down here sec squared t, and here we could write down 1 over 2 of square root of tan t. Now d of dx u, right? So d of dx, what is the value of ux? Ux was x squared plus 1. So x squared plus 1, so this was ux. So the result will be 2x, right? Now let's plug in this value, which is this one, and this value, the result is this one here. So it will be sec squared t over 2 of square root of tan t, and it will be 2 of x, right? So let's use the different color pen, as you can differentiate. Okay, now the main equation was, or main function was f of x, and this is differentiate with respect to x. So here the final answer will be 2x, and it will be sec square. And what was t? T means actually ux, right? T means actually ux. So ux means x square plus 1, so it will be x square plus 1 over 2 square root of tan, again t define x square plus 1. So this is the final answer. So in this question, mainly we have to find the gradient for the curve of y equals to 2x cube, and the gradient we have to define or determine at point 3. It means the value of x is equals to 3. So the gradient of the function, let's derivate with respect to x. So d of dx to x cube, so it will be 2.3 x square, so it will be 6 x square. Now plug in the value x equals to 3 here, so 6.3 square, so it will be 54. So at 3 the gradient is 54.